Hello, welcome to the homework helper on calculating probabilities for multiple loci. This does assume that all of the genes are assorting independently. For this exercise, we will look at one cross, big A, big D, big E, big G, crossed to big A, little d, big E, big E, Y. So you first might say, why is there a Y chromosome? This is indicating that this is the Y chromosome and the G locus is located on the X chromosome. So this second parent in our cross is our male parent. And here is our female parent. Let's look at the first question. How many different gametes can be produced by the female parent? The rule is 2 to the nth power, where n is the number of heterozygous loci. So I have 1, 2, 3, 4 heterozygous loci here. 2 to the 4th power. And let's see, 2, 4, 8, 16. That's going to be 16 different gametes. Now let's look at the male parent. The rule is still the same, but we have to think about the logic of the rule because we know a male can't be homozygous or heterozygous for genes on the X chromosome. He's hemizygous. He only has one copy. Well, the idea here was that for each heterozygous locus, we have 2 different gamete types, big A and little a. So based on that, this male produces 2 different gamete types. He produces the X chromosome with his G allele or the Y chromosome. So for the purposes of this formula, we would count this as being heterozygous, even though the correct term is hemizygous. So now looking at the male, he's heterozygous for the A locus, homozygous for D and E. But remember, we count this hemizygous locus also. So we would have 2 squared equals 4 gametes from the male. The next question has to do with probabilities. What is the probability that the first child from this cross will show the dominant phenotype at each locus? I like to do simple one locus Punnett squares. So starting with the A locus, big A little a by big A little a, female parent gamete, male parent gamete. It does not matter if you write the male across the top or down the side. We'll fill that out. For the D locus, we have big D crossed to little d. So there's only one gamete type from this second parent. For the E locus, we have big E crossed to big E. So there's only one gamete type here as well. And then finally, the G locus. Half of the female's gametes are big G, half are little g. On the male's gametes, he either gives his big G, which is on his X chromosome, or the Y. All right. So this sort of scrap work can help set you up for the rest of the problem. And I'm going to just bring it down so we can use it when we answer these questions. What is the probability the first child from this cross will show the dominant phenotype at each locus? Here we multiply the probability of getting a dominant at the A locus, 3/4, times the probability of getting the dominant at the D locus, that is a capital D, so 1/2, times the probability of getting the dominant phenotype at the E locus. They all will get the dominant allele, so that probability is 1, times the probability of the progeny having the dominant allele, the dominant form, at the G locus, and that is 3/4. If I multiply this together, I've got 9 over 1632. And 9/32s, if you punch that in your calculator, is 0.28125. Now let's try the next one. What's the probability that the first child from this cross will be a son with genotype big A little a, 2 little d's, big E, little gy? Again, we will be multiplying the probability of what we want at each of those 4 loci together. Half of our progeny are big A little a. For little d, 1/2 are little d, For big E, 1/2 are big E, And for little gy, only 1/4. So if I multiply this together, 132. And I can divide that out in my calculator to get the decimal digit 0.03125. I hope that has been helpful. I'm going to just leave this work right there for a second so you can take a peek at it. I hope you have a wonderful evening. Thank you.